Well, hello there, Math126 fans. Something on the discussion board says there may be a typo in the solutions to this exam and this question. I have decided rather than go see if there is a typo, I'm going to solve the problem. We're going to see what happens. And then we're all going to discuss if there's a typo or not. I feel like that will be more informative for all of us. If at the end of all that we decide there is a typo, I'll let the course coordinator know for the future. But this is a good exercise. Let's say we don't have the solutions. What are we going to do? So this is a partial derivative question. So let me write the function here twice and recap. And I apologize if there's a typo. Typically, the exam archive has been very well vetted, meaning it's been used for many years and most typos have been found. If there is a typo, it's because of somebody like miscopying the answer over. It doesn't mean the exam was graded incorrectly, because when you make a typo and you start grading, you'll find out a lot of people have a different answer than you find your typo. It just means whatever they posted didn't have that part fixed. So anyways, we need to take the derivative with respect to x, and then we need to take the derivative of z with respect to y. So those are the variables. That does mean you're going to need the product rule here. And it does mean you're going to need the product rule here. The other side, though, is going to be fairly simple. Okay, so let's set it up. We're going to do first times 0 to the second plus the derivative of the first times the second equals the derivative of the other side with respect to x. And again, I'm just separating them. So on this side, I know I'm going to have 2x. And for this one on this side, I know I'm going to have negative 2y. Okay, now let's do the product rule. So it's going to be first, and then I'm going to have the derivative of the second. I think I did this perhaps in my solutions video, so I feel like I already did this today. Could be I've just done these so many times. I don't know. Okay, so there we go. There's the derivative of the second plus the derivative of the first, which is dz dx, times the second. And you can always kind of step back and be like, okay, did I do it? Did I do first, derivative of the second, derivative of the first times the second? Okay, so the question wants to know what dz dx is, so let's clean it up a little bit. This feels a little bit like our exam question. dz dx. In fact, there's a dz dx here and a dz dx here, and it's attached to everything in this story. So I think what I'm going to do instead is completely factor it out. And again, I've not looked at the solutions. I'm not going to. We're going to decide this together. We can do it together as a team. All right, dz dx is equal to 2x over that disgusting mess. Z plus cosine of z plus 2. All right. The other one, in fact, now that I've seen this, I'm not even going to take time on this. I'm just going to write my two answers. Negative z sine of z plus cosine of z. And again, I might have made a mistake. We're going to have to work together. 2y, but it would be nice if someone said, yeah, that looks good. Or, Dr. Lovelace, go to bed. You're starting to make more and more mistakes. Okay, either one. Let me know. So I finished that first part. The left-hand side was going to be the same, so that's how I knew that. Then the question says, find the linear approximation when you plug in a 1 and a 1. Okay, so we're going to plug in a 1 and a 1 everywhere. So that's a 1. That's a 1. Is there something I'm missing? Use the linear approximation to the surface at the point where x is 1 and y is 1. This is not x or y. This is z, you idiot. That's what you might be saying. I'm not talking to you. I'm talking to myself. Okay, so there's a 1 there. What is z? So x is 1 and y is 1. And so I get that z cosine of z plus 2 has to be 0. That means one of these has to be 0, but cosine can't be equal to -2. So z has to be 0. All right, that feels better. So z is 0. Hooray. I'm trying to find the tangent plane. So z minus 0 equals x something times x minus 1, something times y minus 1. And now I'm going to plug in 0 for z, not 1. So 0 here, that's going to make that 0. 0 here, that's going to make that 1. So I am getting 2 over 0 plus 1 plus 2. I don't know if that was what the question was about, but that's 2/3, positive 2/3. When I plug in a 1 here and a 0 in the bottom, I'm getting -2 over 0 plus 1 plus 2. So I'm getting -2/3. At the end of the question, they're asking me to plug in 1.01 and 0.98. So I'm getting that z would be approximately, the z you get from the function, would be approximately 2/3 of 1.01 minus 1. Minus 2/3 of 0.98 minus 1. And then we're going to calculate that. So we're doing 2/3 times 0.01 minus 2/3 times -0.02. So let's see what that gives me all together. So I'm going to get 2/3 times, I think altogether that's 0.03. So I'm getting that all together, this is 0.02. So z is about 0.02. So check the solution, someone. Let me know how we did there. I guess a comment is, no, it wouldn't really help here. I was going to say, sometimes you can go back to the beginning of the problem and plug in your numbers and see if they're close. It's harder here because it's an implicit surface. All right, hope that helps.